Hey everybody, welcome to today's lecture for robotics, and today's lecture is an introduction to ROS. ROS is the robot operating system, and we'll be making heavy use of it throughout this course. Now, you're probably thinking, what is this ROS nonsense and why does it exist? Well, the important thing about ROS is that it's an operating system, right? So it exists for the same reason any operating system exists, which is that we need to present some abstraction layer, some way of removing the hardware from the equation. Okay. Now, in particular, the robot operating system is super important because robots are vastly different, right? You could say operating systems in general are useful because they allow us to forget that computers are so different from each other. But are they really that different? I mean, generally, you've got a CPU, you've got some form of memory, you've got some GPU, you've got some storage. So computers are not that different from each other, but robots can be very different. This is because there's a vast array of potential sensors, effectors, and brains that a robot can use, right? So you could have robots that are like the Mars rover. They move on wheels, they navigate some particular terrain. On the other hand, you could have underwater robots. So, suddenly there's a robot that looks like an eel. And those two things are very different, right? Now, if you picture traditional software development, what would happen is you'd be implementing algorithms particularly for one type of robot, right? So let's say you implemented some sort of object detection, right? So that the robot can see objects in its world. You'd then have to re-implement it for every robot that you came across, right? And that's a tremendous cost for no apparent reason. So the robot operating system provides a middleware that provides a consistent interface, okay? And so what it means is that it allows algorithms to be implemented in a robot-independent manner. So that if you have, for instance, the Terminator and Wall-E and a little quadrotor, they've got ROS to be the middleware. And then particular algorithms such as navigation, path planning, object identification can work on all of these robots without being re-implemented. So the same navigation code can just work for Terminator and for Wall-E and for the quadcopter. Okay, so that's an immensely powerful thing. So the next question is, well, how does this work? ROS uses what's called a publish-subscribe model. And in this model, you've got this notion that what you're building is a program as a graph, right? So you've got certain components that are connected to each other to produce a program. Okay, now these components are called nodes. Now those are, loosely speaking, those are ROS programs, right? That's a node. You've then got messages, which can be used to send and receive data between these nodes. And you can picture these as sort of the edges in the graph, right? Messages are published to topics, right? So a topic is just a queue of messages. Think of it as like a notice board. Okay, so if I've got a node that needs to maybe tell people what I'm seeing, then I will create a topic for it. And that's sort of a message board. And when my robot wants to maybe have some processing done on its images, it can take its images from its camera and stick it into some topic. Some other node can then pull the messages from this topic. So say it can pull the camera data, and maybe it produces a list of objects which it can then publish to some other topic, and maybe some navigation algorithm can then subscribe to that topic to make sure it doesn't bump into those objects. So you've got this sort of system of interacting nodes. You've got publishers, which are nodes that publish messages to a topic, and subscribers, which are nodes that read messages from a topic. Now, most commonly, your nodes are going to be both publishers and subscribers. So if they're meant to process some data and produce some output, they're going to read their data from some topic, which means they're going to be subscribers, and they're going to publish their output to some other topic, which means they're going to be publishers. So yeah, a ROS system generally just is a system of interacting nodes, right? So these nodes, they just either publish things to topics or subscribe to topics to read things, okay? Now, for a node to work, the node must specify what topics it interacts with. So, what's it going to read and write to and from, and what message data type it uses. Okay. Now, as an example, we've got topics that can be created through the command called ROS topic. Okay, that's just a useful useful program that we can use for testing. So what I'm going to do is I'm going to start up my ROS system, and if you haven't already installed this on your system, please make sure you do soon. Now if I type ROS topic pub -r10 /pravesh standard messages /string hello world, what that does is it creates a node. So that's a ROS program, right? And that node is a publisher. It publishes at a rate of 10 per second. The topic that it's publishing to is called /pravesh. The type of message that it's sending is a string, which is referred to as standard messages /string. And the actual message it's sending is hello world. Okay, so I can do that. Okay, well, before I do that, I must start ROS itself, which I can do by typing ROS core. Okay, so what I'll do is I'll start the ROS core so that I have ROS running, and then I can publish. Okay, now you'll see nothing's actually happening. There is some notional notice board in the ROS space, and it's getting the string published to it. I can also use ROS topic to make a subscriber to this topic. So if I say ROS topic echo /pravesh, that's going to read from the pravesh board and write what it sees. So you see it's writing out hello world because this guy wrote hello world. So these are two separate nodes that are interacting. So if I made this hello beautiful world, because it isn't it, this side would now print out hello beautiful world because it's just, that's the message it's receiving, so that's what it's going to print out. Okay. So I can also use ROS topic to show what nodes are active. So if I say ROS topic nodes, ROS topic list to see what nodes are active. You can see there's at the moment not much, but if I start publishing to Pravesh standard messages and then I list, you can see that Pravesh is now an active topic. Okay, and I can hierarchically organize these topics. So I can make a /pravesh /some topic or /pravesh /other topic. Okay, and that just allows me to keep this more organized. Okay, so we've already seen the ROS topic command. Now, ROS in general will group things into packages. Okay, this makes it easier to find the things you're looking for. So if for instance, you were looking for things related to the Turtlebot, you'll probably find that there's some Turtlebot packages. As you can see, maybe there's Turtlebot bring up, Turtlebot description, Turtlebot navigation, Turtlebot capabilities. And if I go to one of these with ROS CD, it'll take me to the folder that contains that project, right? But the advantage is now all the nodes that relate to Turtlebot navigation are all sort of grouped in the same place. So I don't have to figure out where they are. I can use ROS run to launch nodes. And there's another thing called ROS launch, which is almost like a batch file or a shell script in that it just combines a whole bunch of ROS runs, right? So if I was going to have to start up a whole pile of different nodes, because remember ROS is a system of a system of interacting nodes, right? So to make anything happen, I have to start like 30 nodes, and I don't really want to do that because I'm lazy, right? So I create a world file, which is like a script file or a batch file, and I can use ROS launch to run it. As an example, if I ran ROS launch turtlebot bring up minimal.launch, that would start a turtlebot, I'm not sure if you've all seen the Turtlebot, but if not, Google it. It's quite cool, or you'll see it in the gazebo simulation. But the point is, we have two of these in the robotics room, and if your computer happened to be plugged into a Turtlebot and you ran this, you'd be controlling the actual Turtlebot, right? On the other hand, we often work in simulation, and if you wanted to start the system that okay, let me kill the ROS core. If you wanted to start the system that we use to manage a virtual Turtlebot, a simulated Turtlebot, you can type ROS launch Turtlebot gazebo Turtlebot world.launch. Okay, and if you do that, you'll see a Turtlebot. This robot over here is the Turtlebot. Okay, now what's powerful about the way ROS works is that because of this abstraction layer, because of this middleware of ROS, it doesn't matter that I'm controlling a virtual Turtlebot versus a real Turtlebot. My program will look exactly the same because it can't tell, right? There's just a node there that is consuming my commands and doing stuff, and a node that's producing images, and that's whether it's virtual or real. My program doesn't really have the ability to tell. Okay. Now, if I ran ROS topic list now that I've got the Turtlebot open, you'll see there's a whole pile of topics, right? So the Turtlebot started up its camera, it started up its laser scanning sensors, it started up its velocity subscribers, it started up the mobile base, and all of that was through that world file, right? So it was kind of like a shell script. It started everything we needed. Okay. Now, these topics, camera, image raw, camera depth, image raw, this is camera RGB. The Turtlebot publishes stuff to these topics, right? So that it can give us that data. So if we wanted to, for instance, navigate using the camera data from the Turtlebot, we could subscribe to the image raw topic, and we'd get images from it. Similarly, if we publish to mobile-based commands velocity, that is a topic that the Turtlebot subscribes to. So if we stick messages in there, the Turtlebot will respond to them, meaning it'll move around. Okay, and we can connect stuff. So we can connect, for instance, an image view node to the image raw topic, and we'll be able to see what the Turtlebot sees. Similarly, we could publish using ROS topic to that mobile-based commands velocity topic, and we'd see the Turtlebot move. So as an example, if I wanted to subscribe to the image view, I could say ROS run image view. So this, now we're using the image view package. Remember, we said ROS nodes are grouped into packages. So that's the package we're using, the image view package. Then we're starting up the image view node. Okay, it happens to have the same name as the package, but that's not really necessary. And one of the parameters we're sending it is a parameter called image, and its value is going to be /camera/RGB/image raw. Okay, and what it'll do then is it'll give us the camera data. So this is the camera data from the Turtlebot. Okay, if you look at the Turtlebot in here, what it's looking at is this corner of the box, right? So when we see the image view, we see that same corner. Okay, it looks a bit silly, but yeah. And then similarly, we could use ROS topic to publish a velocity message. So this would be a decent idea, although pasting that's going to be a problem. Okay, so we could use this command, and if we didn't have these bullet points here, which maybe I should take out of the slides, I would do it that way. As it stands, I'm going to be lazy. You're going to hear that a lot in my lectures because I am an extremely lazy person. And what I'm going to do is start up a graphical interface called RQT. Okay, this is a tool you're going to use a lot. And RQT is basically a front end to all of this ROS stuff. Okay, so I'm going to use the message publisher plugin. And then it says, well, what topic do you want to publish to? Okay, so looking at this, it's mobile base commands velocity, right? So that's what I'm going to do. I'm going to go to mobile base commands velocity, and I'm going to hit plus. Okay, so it's gone and made a message for me. And this message has a linear XYZ and an angular XYZ. Basically what that's saying is that in the three planes of existence, X, Y, and Z, I can move in either of these planes, so sort of translate, across them, or I can rotate. That's my angular velocity. Okay, so let's see what effect this has on my image view and my turtlebot. So let's say I wanted to rotate on the spot. Now, the turtlebot, can it rotate around X? Not really, right? Because that would be like it's tipping over. It would be like doing that, which doesn't really make sense. Can it rotate around Y? Well, that would be sort of doing that, so no. It rotates around Z. Z is the axis that goes sort of up through the camera. The blue line that you see here is Z, right? And it rotates around Z. Now, if I wanted it to rotate around Z, what I could do is I could put some value, some non-zero value here, let's say 0.3, and then tick this checkbox to say that it should start publishing. Now, when I do that, you'll see the robot starts rotating. Okay. If I look at the camera image, you can see the camera image is now changing as well because I'm subscribing to that camera. Okay. Now, I could only rotate around Z because that's how the turtlebot moves. Similarly, the turtlebot can only sort of translate along X, right? Because it can only move forward and backwards. So let's give it a velocity of 0.1 in the X direction and click it. And you'll see that it now moves. Okay, you'll see it's jerky. And the reason it's jerky is because the turtlebot actually listens for, I think it listens at 3 Hertz, and I'm only publishing at 1 Hertz. So if I change that to 3, I'll now get a smooth motion, right? What was happening before is that the turtlebot was listening for messages 3 times a second, but I was only sending 1 a second, meaning it'll move for 1/3 of a second and then stop for the other 2/3 of a second. But if I publish 3 times, then it'll just carry on. Okay, so experiment with this stuff. The best way to learn is to just do random things and see what breaks and see what doesn't break. So I jumped ahead a bit and talked about RQT. Another useful thing, there's a lot of useful things in RQT, but another one that's quite cool is to look at the node graph, which tells you what nodes are in the system. So what programs are currently running and how they're connected. So you can see there's all sorts of stuff going on. Okay. Okay, and that's basically RQT. Now, ROS programs live in packages, and ROS packages live in workspaces. Now, if we wanted to write our own programs, we'd have to create a workspace. So you'll see in the slides, which you'll find on next to this video, that there's a whole sort of step-by-step thing on creating a workspace. I'm not really going to go through it in the lecture because it's kind of pointless. You'll just see me typing the things that are actually in the slides, and they'll work, which, so whatever. So I want you to go and do this on your ROS system, and you'll see, a pile of useful things happen. Now, generally, when you're creating your program, you're going to want to publish and you're going to want to subscribe, right? That's how anything in ROS happens. So the examples provided here are a talker and a listener. And so that means you can see how in Python you'd set up a publisher, meaning something that sends data into the ROS environment, and a subscriber, meaning how you'd get data from the ROS system from some topic and how you'd do something with that data. Okay. On the last slide, you'll see there's some instructions that say you should install the AR drone simulator. So I want you guys to try this. The AR drone is a quad rotor. Okay, so when you're looking gazebo here, you're seeing this ground-based robot. When you've installed the AR drone simulator, you can launch it using its own ROS launch, and what you'll see is the quadcopter. Okay, so in this week's lecture, all I wanted you to do is sort of play around with ROS. One of the reasons that the lecture is quite light is because I know you're going to spend quite a bit of time getting ROS working. But the other reason is because what I want you to do is to go to the ROS tutorial. Okay, so what you need to do is go to, okay, I'm just going to say ROS kinetic tutorial, and you will find this one here, right? wiki.ros.org/ros/tutorials. And you'll see a set of tutorials that basically take you through how ROS works. It's all quite mechanical. It's all just about what to type in order to do particular things and how to use nodes and topics and services and that sort of thing. And I would suggest you get all the way up to 15, right? But it's quite useful even to get to 18, which is reading messages from a bag file. It's quite a useful thing if you're going to end up doing research involving robotics. But you can sort of ignore the C++ stuff because we're not going to be using C++, unless of course you're really keen on C++, in which case my sympathies. But go with Python in general, and yeah, just go through this entire tutorial. And Monday's lab will require you to already know this stuff. Okay, now I know it looks like a lot. It looks like you're going through 18 pages of stuff, but none of them are really, I mean, it's really not, it's not challenging. See, you just fundamentally tells you what to type and what typing those things will do. Okay, and is all quite useful stuff. Okay, so yeah, I hope you've enjoyed that introduction to ROS, and we're going to be doing some really cool stuff with it. This system is extremely powerful and will allow us to do cool things. If you're still having trouble setting it up, please make use of Discord. What you'll find is that if I can't help you, some other person in the class will be able to help you. But the point is, you will be able to do this. If you're not yet on the Discord group, please get on the Discord group. Yeah, thank you, everybody.